Good morning, students. Now, still we continue with message authentication and hash function. At last, we are still continue with message authentication code and security, unit number 5 and 6. Now, we seen the message authentication code is a cryptography. Sometimes it's known as a tag, is a short piece of information used to authenticate a message. In other words, to confirm that the message comes from the stated sender, it is just a like authenticity and has not been changed, modified, or altered. The MAC value protects both the message data integrity as well as its authenticity. You must aware with data integrity is a maintenance of and the assurance of accuracy and consistency of data over its entire life cycle and is a critical aspect to the design, implementation and usage of any system which stores, processing or retrieve a data. The term is broad in scope and may have widely different meaning. This is all about data integrity and we are learned message authentication code as well as authenticity. You must aware which authenticity is a data origin authentication property that a message has not been modified while in transit and that the receiving party can verify the source of the message. Authenticity means sender and receiver both are verified the message and the originality of transmitted data. Its data integrity and authenticity is used to verify to detect any changes to the message content and who also possess the secret key. Here we see in definition is a message authentication code system consists of three algorithms. A key generation algorithm select a key from the key space uniformly at random. Sign-in algorithm is used to efficiently return a tag given the key and the message. A verifying algorithm efficiently verifies the authenticity of the message given the key and the tag. That is, return accepted when the message and tag are not tampered with or for and otherwise return rejected. For a secure, unforgivable message authentication code, it should be computationally infeasible to compute a valid tag of the given message without knowledge of the key. Even if, for the worst case, we assume the adversary can fork the tag of any message except the given one. Formally, MAC system is triple of efficient. It's used the algorithm G, S and V satisfying. Here we use G for key generation, S for signing and V for verifying. Here we are also talked about security. While MAC function are similar to cryptographic hash function, they process different security requirements. Now you heard a new word, cryptographic hash function. Short form is CHF, is a hash function that is suitable for use in cryptography. It is a mathematical algorithm that maps a data or arbitrary size to a bit array of fixed size and is a one-way function. That is a function which is practically invisible to invert. To be considered a secure MAC function must resist existential forgery. Now, existential forgery means what? It is ability to create a pair of consisting of a message. There are different types of forgery under chosen plain text attacks. Means even if attacker has access to an oracle which processes the secret key and generate a max for a message of the attacker's choosing. The attacker cannot guess the MAC for other message which were not used in query the oracle without performing infeasible amount of computation. MAC differ from digital signatures. MAC is differ from digital signatures as the MAC value are both generated and verified using the same secret key. This implies that the sender and receiver of a message must agree. Sender and receiver of message must agree on the same key before initiating communication, as is the case with symmetric encryption. You are already learned in unit number 1 symmetric encryption. We are also learned symmetric key algorithm are used for cryptography. Cryptographic key used for both encryption of plain text and decryption of ciphertext. Key must be identical or there may be simple transformation to go between two keys. For the same reason, MAC do not provide the property of non-repudiation. You are also aware with non-repudiation, the situation where a statement author cannot successfully dispute its authorship or validity of an associated contract is offered by signature, specifically in the case of network-wide shared a secret key. Any user who can verify a MAC is also capable of generating MACs for other messages. In contrast, a digital signature is generated using a private key of key pair, which is public key cryptography. Since this private key is only accessible to its holder, a digital signature proves that a document was signed by none other than that holder. Then digital signature do offer non-repudiation. However, non-repudiation can be provided by systems that securely blind key usage information to the MAC key. The same key is in the possession of two people, but one has a copy of the key that can be used for MAC generation, while the other has a copy of the key in hardware security module that only permits MAC verification. This is commonly done in the finance industries. Now we are completing this title message authentication code and also learn a security and comparison of cryptographic hash function by using example of Oracle. We are also compare MAC with digital signatures. We also cover and revise symmetric encryption. non-repudiation, share a secret key, and hardware security modules. Thank you. Jai Swaminarayan.